Okay, so by now you have learned recursive formulas, and if I asked you to just write a recursive formula for me, that's one of the tasks you'll have to do for the test. Let's say you start with 2, and then you go up by 6 each time. Write me a formula for that. Starting with 2, you're going up by 6 every time. Right away, I hope you slapped a U1 on your paper. And then there's a whole bunch more to it. Started with 2, go up by 6. Now I'm going to ask you, in this case, these formulas are kind of long and hard for me to check, so I'd like you to compare with the person across from you. So these 2 rows compare, these 2 rows compare, and these 2 rows compare. If you got nobody next to you, then you just do a diagonal. Joe, could you compare back also? All right, thank you. Is anybody forgetting the n is greater than or equal to 2 thing? I'm sure some people probably did. I won't put you on the spot, but that's a really common thing to forget. We started with 2. Un equals un minus 1 times, actually it's not a times, I said to add 6 every time, so I'm going to go plus 6. And then n greater than or equal to 2. All right, let me explain a little bit of the difference now on arithmetic versus geometric. What kind was this? This one's arithmetic because we added something. Okay, if I changed this right here to say times by 1 plus 0.05, do you get that 1.05 is something and 0.05 is something different? One of them is the common ratio, and one of them is the growth rate. Would you please write CR and then tell me what that is, and the GR and tell me what that is? The common ratio is one thing, and the growth rate is something else. Please write down what the 2 things are and show them to the other person, see if they agree with you. The common ratio is one thing, and the growth rate is something else. Yeah, it's a good question. Should you put your growth rate as a decimal or should you get it as a percent? It's probably better if you put it as a percent. The growth rate should be a percent. Okay, the common ratio, 1.05. It's that whole thing. The growth rate is just that part. And instead of saying 0.05, say it like you mean it, 5%. Make sense? All right, I'm going to give you another one that's similar but different. I'm going to tell you the situation, and you write me a formula. You can just erase a couple things because your formula is pretty much going to stay the same, see? All right, I want you to start with -10 this time. And we're going to have it decay, as in shrink by 5%. Starting with -10. And this time it's not a growth rate, it's a decay rate, 5%. Then tell me the common ratio and the decay rate. Give the person a second. Pause for a second while you work on that. Okay, so you should have said, we started at -10, and it's a decay rate, so it's a 1 minus something. 1 minus 0.05. Okay, and then the CR is the whole thing together, which would make 0.95. The decay rate is the 5%. It's 5% decay. How many of you had that one right? Good. And you're catching on some of the more tricky parts. That's awesome. And if I give you 2 terms, let's see if you can tell where it's going. 2, 2.35, ... Can you tell where that's going? That is the question. You are right. You cannot tell where this is going right now, because you don't know if I added something or if I multiplied by something. Do you? All right, so ask your question again louder. Yes, it's geometric. Because if I didn't tell you that, you wouldn't know if I added 0.35 or if I multiplied by like 1.25 or whatever. All right, so it's geometric. Now, as soon as I say geometric, that should tell you whether I added or multiplied. Now, if this is the pattern and it's geometric, I'm going to ask you to do 3 parts to this review question. It's going to be, what would be the formula? What would be the 10th term? And you're going to want to put that in the calculator to do, because you don't want to have to deal with that one. And lastly, I'd like to know 3 points on the graph. If I said to graph this, I think some of you would be lost. And I'm going to show you in a moment how that works. But for right now, everybody just work on getting the formula. If you don't know the formula, watch me really close and take good notes. The 10th term, calculator would be handy for that. And 3 points on the graph. When I say points, I mean like what comma what. You know, like 2 comma 4.75 or whatever. I think I'm going to stump some of you on this one, or at least on the points in the graph part. Well, maybe not. It's not supposed to be super hard, but I'm going to pause for a second. All right, I hope that was enough time to get you through this. I need you all back with me now. If you were doing other things, that was okay, but now I need you back. All right, so hopefully you divided, because we knew it was geometric, was a multiply thing to get from here to here. So it's a divide thing when you're going from here to here. So you go 2.35 divided by 2, you get 1 point what? 1.175. Okay. If you have 1.175 in your formula, that is called the common ratio. Okay? That is 1.175. Okay. So now my formula should be U1 equals the first number, 2. UN equals UN minus 1. That's any term is given by the term in front of it times 1 plus 0.175. Now, why do I make you break it up like that? Because now you can see the rate. The growth rate is just that part. That part right there is the growth rate of 17.5%. Notice I moved the decimal over 2 spots. 17.5% growth. Okay. Now, needed n is greater than or equal to 2. Okay? How many of you had that part right? Okay, good. Now once I've got that in the calculator, I can just type in on the main screen U sub 10 equals, and it will tell me the answer. Now you could have also looked it up on the chart. Okay. JH, what did you get for U sub 10? It's a decimal, I know. Okay, all right. And next time, work with your partner to look at their Y screen. And unless both of you were having that same trouble, that would have helped. All right. Let's go over here. Mr. Q, what did you say the 10th term was? 8.53. Can anybody verify that number? I'm seeing some nods. Okay, I got you. So about 8.5-ish? Okay, good. It's just a decimal question. And where we would have you round to is important, but I didn't say where to round, so I'll say 8.5, close enough in this case. All right. Now, if you needed points from the graph, do you get really what you want then is just to hit the table? Everybody go to hit table right now on your calculator. Go to second table. Do you get that? Gives you a list of points. 1, comma, etc. All right, I'm going to go and change mine to be the right formula here. It starts with 2, and it goes up by 17.5%. Hold on just a second. 175 right there in parentheses. And then I can just go to my table, and there's a list of points right there. So if I was going to graph this, I'd graph 1 comma 2.35, 2 comma 2.276, 3 comma, get the idea? These are the points. That's what you'd graph. Okay? That comma that. Now another way to think of this is, would you agree that this very first term was, the way we're doing it right now, was u sub 1? So it's really true that u sub 1 equals 2. How, isn't that supposed to make, wait a minute. I did u sub 0. Uh-oh, my bad. My bad. Look at my formula. You see at the very top of my y equals screen? I started with u sub 0. Because later today, we're going to be doing a lot of our problems with u sub 0. Sorry about that. Okay, I realize why. If you were looking at your chart and you were like, wait a minute, my chart looks totally different. It's because I had started with u sub 0 instead of u sub 1. Okay, so there's my list. 1 comma 2. Sorry, and I noticed that because I was doing this. u1 equals 2. 1 comma 2 is your first point. This one was u sub 2. And 2 comma 2.3 then. See, 2 comma 2.3 is your next point. All right, 2.35. All right, so there was a lot of topics in there. Yes, sir. Yes. Can you avoid this plus is what you're asking me. And I agree, of course. 1 plus 0.175 is 1.175. But I want you to get used to putting in a plus because I know where we're going. And where you're going by the end of next week, let me show you what the formulas always look like. Usually have bigger numbers in them, but that's no big deal. Okay, so they get more complicated. And they always have a plus or a minus in them. That's why I'm asking you to do that. Because it gets you used to the way they're going to look later. Okay, the only difference here is this is called a shifted geometric, but it's because it's shifted 7. Okay, and this would be like a $10,000 investment in the stock market, and it's growing at 3%, which you actually would have understood before. But this part compounded monthly and growing by $7 a month. You're putting $7 a month into this account to make it grow more. Okay, so you're not ready for that yet. I'm just saying all that's new really is this and this. That we're going to add that next week. Okay, but for right now, your problems would have looked like this. Without that, and without that, and now that's something you should have been able to relate to. 1 plus 0.03, it's growing by 3%. But because of where we're headed, that's why I want you to keep putting this plus in there. Okay, enough about that. That's kind of the review stuff. The new stuff is, by reviewing that much with you, the new stuff isn't going to be too tough at all. All right, so here is an example of a house that's for sale in Maple Grove. Okay, one of my colleagues lives in Maple Grove. I was doing some searches on the internet, and back a few years ago, the prices on houses had gone down dramatically. So this is a $119,500 condo. It's a townhome. But the thing I thought was really cool about this was not that. $119,500. It's the next slide. That the sale price in 2004 had been $193,000. The point? They're selling it right now, well, they were, for $119,000, and it used to be $193,000. That's gone down from it was this in 2004 to I took this other one in like 2009, and look at the price drop from there to there. Holy smokes, the poor people lost $70,000 on their home. That's a lot of money. I mean, we talk about how people are really happy that gas prices are cheaper. The average person is saving $700 on gas this year. That's nice, but when you lose $70,000 on your house, it makes, that hurt a lot of people. So this was just recently when we had the big drop in value of homes, and that had never happened before. In fact, people were saying that that's never happened. That sort of implied that could never happen to houses that go down in value, but they did. They went down a lot. And if we get a huge, crash in the economy or a huge crash in the stock market, houses could go down a lot again. It happens. All right. So the point is, we're going to be dealing with some real-world situations like this and talking about percents of decay. In that case, that was a percent of decay, the decay in the value of the house. It went down, 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 down. Now it's reached a bottom, and now the houses are going back up again. They're not nearly as high as they used to be, though. You can still buy a house today way cheaper than you could have in 2006. Just for perspective, that's how many years later? From 2006 to 2015? 9 years later, it's still way cheaper to buy a house now than 9 years ago. So it's interesting how houses actually decayed in value. All right, we already knew this. The growth was 1 plus the percent change, and decay, it's 1 minus the percent change. We've done this over and over again, so you should be good at that part already. In 2006, a small town has a population of 1,500. However, it's predicted that the population is increasing by 3% each year. Write a recursive formula to model the situation. This one should be a piece of cake, but here's the catch. Instead of starting with u sub 1 being 1,500, what do you think I want you to start with? U sub 2006, that's right. Okay, so write me a formula for this. Get on this slide. U sub 2006 equals, and it's still un minus 1. I mean, that's always going to be there. So we're going to play around with different numbers for our starting value. Because the cool thing is, when you put this into your calculator, it says the year right next to how many people are living in the town. Instead of something obscure like u sub 3 is, however many people are in the town, it says u sub the year, and then it tells you the population. Okay, so it should be 1500, and hopefully you knew enough to put 1 plus 0.03. You get that? Now technically it needs a domain, n greater than or equal to what this time? 2007. You always go one bigger than whatever this number was. Okay? All right, now you'll need a calculator for this one, definitely. So grab your calculator, but again, you don't have to change everything. That u sub n minus 1 thing can stay the same. The top number needs to change, though, 2006. And as I move down here, I'll just arrow through all the stuff that stays the same. Notice the 1 even stays the same. And we're still growing, so it's plus. And this time we're growing by 3%, so I'm going to say 0.03. And I'll delete that last number. There we go. And my starting value is 1,500. So if you go to the table, here's the problem. Your table says error back there because that's u sub 1. Did we ever tell it what u sub 1 was going to be? No, that's why it doesn't know. We'd have to change our table to start counting in 2006 because that's what we had in there, remember? So we got to go to our table settings, which is right here. Everybody look at what button I pushed that's red right there. Above the window is table settings. And now we got to get our table to start counting from 2006. That was again above window button. It says table set. So you go second window, that gets you the table settings. Okay, now I'm going to go to my table and see if it's making sense now. It is. 2006 is 1,500, just like I wanted. So then I can see in the year 2013, it's 1844 population. So the question was, what will the population be in 2020? Well, I got it up to 2016, so I guess I got to hit the arrow down a bunch of times until I get to the year 2020. Only thing that was tricky about this one is that we changed the starting number to the year 2006. So there it is. And remember, if I want the exact answer, I got to get on top of that. Does it ever matter that it's, yeah, it sometimes does matter if we ask you to round to the thousandths place, or even the hundredths place. So you got to get right on top of that number to see the exact right answer. It's a good point. With people, you absolutely would round it because you don't have 0.88 of a person. But I'm just trying to reinforce, some of my colleagues feel really strongly about this, that, you know, if you don't have this number, you don't have the exact answer. And it's true. It's just usually when you round it, it doesn't matter anyway. Okay. So let's see if we can get the final question answered here. When will it reach 5,000? Well, I can just keep on arrowing down until it hits 5,000, or I can like skip ahead a ways. Like I can tell it's not even close, is it? I'm gonna maybe change my table settings to start at 2030 and see what happens. 2030, and see if I'm close now. Uh-oh. Didn't like that. I'm going to go back to the table settings and see what I did wrong. Seems like 2030 should have worked. Oh, there we go. I just must have hit a button wrong. Okay, so when will it hit 5,000? Still hasn't hit 5,000. This is just kind of a guess and check thing. You just keep on trying. I'll just hit the arrow down arrow a few times and find it. So it's at 4,000, so I got to keep going a little further. Is there an official mathematical way to do this? Of course there is, but it's really complicated and probably not worth learning. The way I would give you is you would want to graph it, and then you'd graph another line at 5,000 and see where the graphs cross. But that would be much more complicated than just hitting the arrow down a bunch of times. In the year 2046, it hadn't reached high enough. In the year 2047, it's high enough. So your answer is 2047. Now, what if they got really picky and said exactly when in 2047 it hits it? Well, then they would have had to tell you, were they taking their population measurement on January 1st? Or were they taking their population measurement on December 31st? You know what I mean? Makes a difference. So they'd have to be much more specific with you if they were going to be picky about exactly when it happened. We can just go by, well, it wasn't big enough in 2046. It is big enough in 2047, so the answer is 2047. Yes? I get what you're saying, and because they're not telling us, that answer would be okay. But if the answer of between 2046 and 2047, because it's actually showing that you're smart enough to know that you don't know, you weren't given the date that it happened. But the safer answer, the safest answer is just in 2046, it appears from our chart that it's not there yet. So we have to assume it's by that these on the chart are the end of 2046. So probably safer to say 2047. Okay. I think you covered everything that you need to know for this stuff, but we're going to do another one just to be sure. Everybody try this one, and I want you to compare it with the person next to you when you're done. Remember, cars do not grow in value unless you buy collector cars. Loses 1/8 of its value means it's decaying. And that's what cars do. It's really depressing. You can buy a new car and a year later it's worth like $4,000, $5,000 less than what you paid for it if you wanted to sell it. I'm going to pause for a second while you give that a try. Here we go. A car loses 1/8 of its value. Right away I'm thinking 1/8. What's that? Well, I divide that and I get 0.125. That means that it's losing 0.125. So it's in the formula, U sub what? Well, if you don't have a number like a year, it said when it's new. It didn't say what year it was. I would recommend you do U sub 0. Now you can do this problem with U sub 1, but then when you get to this 6 years thing, I bet you did U sub 6 and you'd be wrong. This is why on real world problems you need to start with U sub 0, because If you want the value in 6 years, that will then be u sub 6. If you had started with u sub 1, it would technically be u sub 7. You see how confusing that would be? So just always start your real-world problems with u sub 0. U sub 0 is the total at the beginning, right there, 23999. And then un minus 1, 1 minus that, 0.125. There's your formula, and I bet you, how many of you did I catch on this that you didn't know about starting with 0? Be honest. That's almost everybody. Okay. That's the big difference for today compared to yesterday. Today we're doing real-world problems, and if we say after 6 years, you're going to think you want u sub 6, so you better change this to u sub 0. That means we start, before time even starts, the car's worth this. And then 1 year later at u sub 1, you get how u sub 1 needs to be the next year, the year later? Okay, so if you don't understand why, you just have to trust me. If you're doing a real-world problem, start with u sub 0, and you then can trust the rest of the numbers in the problem and go to 6 years is u sub 6 then. Okay? All right. Now let's do your homework together. Everybody take out your homework. It's, you know where it is, I hope. And it looks like this. Now with this hour, I'm going to have you skip a couple of them. You guys may skip problems 2 and 4 because we don't have as much time as I would like. So, number 1 is a simple one. It's just give the real world meaning for this. All I'm saying is 100 like the number of chickens in Bolivia? Not probably. Let's look at what 100 might be in the real world here. It's starting with 100. Don't say starting value. It has to do with the question at hand. Is it about cats? It's about bouncing balls. So what do you think the 100 is? If it's talking about the bounce of a ball, it'd be the height of the ball. And it is the first one, right? So you could say the starting height of ball. How about the point 2? If we're talking about a bouncing ball, the balls get higher and higher and higher as you bounce them. You drop the ball, it bounces and then it goes a little lower, and it bounces, goes a little lower, bounces, goes a little lower, etc. So then that must be a what rate? Decay rate of bounce, or of the height of the ball after it's bounced or something like that. But I'd be fine with the way I wrote it. Said you could skip 2, that's fine. Let's go to 3. I've got a chart here, and it's saying basically that I should start with u sub 0. Can you see why it's saying I should start with u sub 0? Because of that right there. It's saying when you start this problem, you have $2,000 in your bank account, and 1 year later, you've got $2,170. This is exactly why we should start real-world problems with u sub 0. So u sub 0 is how you start, and it's 2,000. un minus 1, and then what's it growing by? Well, that's not fair. It doesn't say what you're growing by. It does. You take this and you divide by that, and you can tell what it's growing by. And then I would probably, once I got the formula, want to put it in my calculator to do this part. The value after 14 years. If you start with u sub 0, you can trust it. It'll be u sub 14. All right, and if I look down in here, basically there's just it's the same kind of concept over and over and over again. You're just trying to find your little formulas, put them in the calculator for sure. Always start your formulas with u sub 0. And you probably can get your answer off the chart or the table every single time. Here, I guess, I'm sorry, this is one exception. Everybody go to problem 5. You might want to print yourself a u sub 1985 to remind yourself that that's how I would start this problem. Not a u sub 0, because they gave me the year. It's so much smarter to do u sub the year. That way you can tell what year it reaches, you know, what the number that they want or whatever. Like, so anyway, if you start with u sub 0, you could have done this problem, but it would be much more complicated to figure out when to end. If you start with u sub 1985, then when you look on your chart, it'll say like 1986, 1987. It'll be written out really nice for you. Okay, on that note, remember that your chart, the starting value in your chart is going to start at 0. So if you want to look at 1986 in your chart, you know what I mean? This isn't a 0 anymore, it's a 1986. You've got to go and do your table settings like I did here, and go to my table settings and change that number to whatever it is you started with. So if you're going to use u sub 1, you probably want your table to start at 1. If you're going to use u sub 1985, you probably want your table to start at 1985. Don't forget your table setup. Okay, that should cover it. Your homework is everything except problems 2 and 4. And it's a pretty shortish worksheet, I think you'll see. And then tomorrow's a review. And then Monday's the tests, and hopefully you'll have learned a lot by then and can start off the semester with a nice straight A. Which would be awesome. All right, that's all I have for you for today.